What they are saying that the A1, A2, A3 be a sequence denoted by A, and the sequence delta A is defined such that delta A is the following sequence: A2 minus A1, A3 minus A2, and so on. Suppose that all of the terms
Yes, sir.
of the second difference, yes, is 1, correct?
Yes, sir.
Then, and also A20, A19 and A92 is 0. So let's try this way. The first way what you can think that this is actually, we assume like A2 minus A1, let's say A1, maybe you assume.
We can
Correct.
define that the sequence delta of delta A is
Define
AK
this.
plus 2 plus AK, where K goes from 1 to
Wait.
infinity.
Yes, yes, yes. That's correct. Let me. So the idea is what you're saying, that let's say A1, A2, A3, A4 dot 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 till AN. You are taking the first. That is correct.
Yes, sir.
Now the second time, what is happening? That you are taking A2 minus A1. This is delta A. This is A, by the way, and this is going to be delta A.
Yes,
Delta
sir.
A, what is that? A2 minus A1.
A2 minus A1, A3 minus A2.
A3 minus A2, and so on. And you take delta delta A, automatically it become a constant. It means what is happening over here is interesting. See, this thing I'm assuming, let's say A U1 actually. This is U2. Similarly U3 and so on. So basically delta delta A is coming out to be U2 minus U1, then U3 minus U2, and so on. And
Yes,
each
sir.
of such difference, what you are getting in the second iteration or second difference, that
All
is
of the
going to
terms
be
are equal to 1.
1. Now, what is the point they want to convey? Actually, we don't have to do that much. Like, we don't have to undo and all these things up to here and then again find out A1, A2. Try to think how actually the A is kind of a function you have given, and delta A, the difference between two consecutive terms. So don't you think it's a kind of a differentiation you are doing? And that second differentiation, you are getting the constant. Because when you do the differentiation, what is the meaning of difference? It's actually when you're taking the finite difference for a very constant gap, then we can say the difference. But we make that gap very close, then it will be differentiation, like derivative,
Yes,
right?
sir.
So
Yes, sir.
can we not just assume that this is a square
Second
and then
derivative.
second derivative? So this, I can state that the first sequence term as a an, can I take as a square, an square
Yes,
plus
sir.
bn plus c? Can I take it like that?
Yes, sir.
So what I wanted to say that this will become a is equal to half,
A will
right?
be
The
1 by
second,
2, sir. Yes, sir.
right? And the screen is visible, no?
Yes, sir. It's visible, sir.
Okay. Now, once you get a is equal to half, again you can apply one trick. The trick is that they are saying that the A19 and A92 is 0.
Yes, sir.
It means I can assume the an as half times n minus 19 and n minus 92. You see?
Because 19 and 92 are zeros.
0, correct or not? So basically
Yes,
they are acting as the roots of this.
yes, sir.
And now they're asking to find out the A3. So substitute A3, means n is equal to 3. So we get half 3 minus 19 and 3 minus
3
92.
minus 92.
Calculate it. 3 minus 19 is minus 16 and 3 minus 92 is
89. 89, sir.
minus 89. So what we get? 89
Into 8.
8. So 2.
712, sir.
712, and that's the answer. Understood?
Yes, sir.
Yeah. See, in this question, what they're asking that, hello?
Yes, sir.
Okay. So see here, the z square minus 6 mod is 6, and they're asking the minimum value of this quantity. So if you understand it this way, let's see, I'm assuming I will solve it in my way, and then again I will also discuss what the students in the class they suggested to do. There's also very smart mode. So let's try. Suppose we have this thing uk is equal to z e the power I k pi by 3, and the vr e the power I r pi by 1011. So you focus on this summation here. Let's call this as S first. So what I'm getting is summation k goes from 0 to 2021, and the magnitude of z, sorry, I've already taken this thing as uk. So uk minus bk mod. So not bkr, actually, not bk, vr, correct? So first you try to fix this thing. So you notice that what is happening, that the value of k is going from 0 to 2021. So they're asking the minimum value of this quantity. So if you try to write in this way, what you write, you can write u0 minus vr plus u1 minus vr all the way up to u 2021 minus vr, and these are 22 terms, correct? Because 0 to 2021.
Yes, sir.
And now you notice what you are doing. You are taking this as a one complex number, the second complex number, third complex number, and so on. So they are the individual magnitudes of each such complex number. And by the triangle inequality, you know that the individual magnitudes will be always greater than the sum of those, correct? So I can write this thing as is greater than all the u0 plus u1 plus u2 plus dot 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 till u 2021 in one group, and minus I will write all the VRs in one group, correct?
Yes.
So how many such VRs you write?
2022.
2022. Very good. You notice that when you're taking this all these things, it is actually the one way to think in this way. Let me just, so I'm writing this is equivalent to there. So what is this? It's nothing but summation r, not r, k goes from 0 to 2021, the u of k, correct? And this is 2022 vr, correct? Now you notice what will happen here is actually we are asking the summation k goes from 0 to 2021 and uk is z times e the power I 2k pi by 6. I can write 2k pi by 6, and why I'm writing, there's a reason. And vr I can write directly there 2 times I r pi, because 2011 will cancel that, correct?
Yes, sir.
Okay. So now what will happen? See, this thing, the z is immaterial. What is the z actually? Z is here. Z square minus 6. Suppose you fix any z from that complex number locus, like z square minus 6. There are many such kind of z is there which will satisfy this thing. One of them is 0 also. So suppose you are setting 0, of course it will be 0. But suppose you are not setting 0, then doesn't matter what will happen, but you notice one thing here, that this is actually what? This is the sixth. This is the sixth root of unity, correct? Yes, 2 pi by 6 means actually 2k pi by 6. When it happens, when k running from 0 to 5, then there will be 6 root of unity will be there or not. For k is equal to 0, there is 1. For k is equal to 1, 2 pi by 6. For k is equal to 4 pi by 6. For 3, it's like that, correct?
Yes, sir.
And sum of all the six of unity will be from, like say, suppose from I'm writing, let's say k goes from 0 to 5 only, and I'm writing e to the power I 2k pi by 6. What you tell? That will be 0, correct or not?
Yes, sir.
And you notice how many total terms are there? 2022. But 2022 is evenly divided by 6 actually. So after 6,
yes,
again it will repeat the next 6 of the same thing.
Yes, sir. So the total sum will be 0.
Exactly. Means this sum total will be 0. And what we got now? This is minus 2, so this is magnitude, so 2 I can take it out, and e to the power I r pi. But the problem is this is only the inner sum we got, correct? And the outer sum is still there. R goes from 0 to 4, correct?
Yes, sir.
So basically we have to append that thing. So summation R goes from 0 to 4, and 2 times, and this magnitude will become 1. E to the power I r pi, whatever you take, magnitude will be 1, correct? Cos,
yes, sir.
Correct, you know that. So this will be 1. So basically you're adding 2 how many times? 5 times, so the answer is 10. And once we got answer 10,
number of integral devices.
So that will be 4 actually, correct?
Yes.
1, 2, 5 and 10. Now what the student suggested is also very interesting. And they're also correct. What they're suggesting that.
One minute, I'll write this down first.
Okay, sure. So what we have to do in it. So what we have to do in it.
One minute, sir.
Idea. Five integers are selected uniformly at random from range 1 to 5, inclusive, and put into a set S.
Yes,
each integer is selected independently of the others. Which of the following is true? The probability that value of minimum element is 2. So how do we proceed? Like the minimum value is 2, let's say we have, it's a random variable question, probability distribution. So M is, let's say, the minimum value. And how do we set that the minimum value? That is, can we guess? The minimum of anything can have minimum value of, what are the numbers I have? 1 to
5.
3, 4, 5. Correct?
Yes, sir. 1 to 5. Sir.
Minimum can be from there only. Yes. So let's take a let's create a general formula for that minimum. So for creating a general formula for minimum, what we can think? So I'm setting that the minimum value is, let's say, k. So how do we write it? Let's set a is belonging from 1 to 3, 4, 5. And then we set we create a general formula, and then in this formula we will substitute the value 2, 3 and so on, and we can get it, whatever we require. So how do we create it? Suppose we want to find the minimum value m is greater than equal to k, some integer. There is a way to write now, the greatest this thing, distribution. So probability of m greater than k, what you write? 1 minus probability of, tell me, m is equal to,
less than,
so is equal to, what are the things we have to write?
less
Okay,
than k, sir.
less than k directly. Okay. So m is less than k. How do we evaluate this thing? Can you do? Any idea?
No, sir.
Now suppose I ask you from this to find out directly without just doing this thing. So what you say? Like I have, suppose I have this k you are taking. So let's say I'm not writing this thing. So what you can say that? It means you can say that a number what we have picked, let's say 1 is greater than k. Or wait, or let's take these numbers we have selected because the 5 elements are selected. So let's say the number selected xi, x1, x2, x3, x4, x. So can we say that the p is the x1 greater than k, or what will can happen? x2 greater than k,
Yes, sir.
or x3 greater than k. I will explain everything, don't worry. And x5 greater than k. Can we write like this?
Yes,
I'm actually teaching how to divide the general formula. Otherwise, we can do for the individual also. No problem. Okay. Individual also you can try and we can do it. Now each number tell me the integer is lying between where to where?
and 1 and 5, sir.
1 and 5. So how do we create this whole thing? So number of, let's say I'm just saying that, okay, xi greater than k here. Xi, suppose I just decide that I'm taking here xi greater than k, and this, how many times you have to repeat if you're writing this thing? 5 times,
Yes, sir.
correct? If I can write this, what is the values of xi you can take? Any idea?
No, sir.
Acha, tell me. Number of integers in the range of 1 to 5, what are those?
5, sir. 1, 2, 3,
But if
4,
I say number of integers in the range 1 to 5 greater than any k,
5 minus k.
5 minus k, greater than equal to they're asking. No? So tell me what will happen. Let me repeat the question. Number of integers in the range 1 to 5 is greater than k, greater than equal to k. Acha, less than,
K minus 1, maybe, sir.
no, you are actually, previously you gave the correct answer, that number of integers in the range 1 to 5 which is greater than k, just tell me.
5 minus k, sir.
5 minus k, which is greater than k, but it can be equal also, na? Then
Yes,
what
sir.
is that? Then what is the answer?
6 minus k, sir.
Exactly. It means this number is 6 minus k, and probability you are finding. So tell me what to write in the denominator.
5 to the power of 5.
What is that?
5 to the power of 5, sir.
5.
Yes, sir. 5, sir. Since you're selecting only one.
Yes. 5. Now this is the probability of E. So let's test it on 2. Correct? So on 2, what we get?
4 by 5 to the power of 5. So
4 by?
4 by 5 to the power of 5.
But the problem is that, see the question. Probability that the value of minimum element is exactly 2, not greater than 2. So for exactly 2, what do you do? For exactly k, how do we devise it? It's a little bit sophisticated. You can also do by doing each of the options and all. But it's not like I'm actually what we call criticizing that method. You can also do by like this. But we can learn this thing also. So tell me, if I have to find the exactly k, means minimum value is exactly k. Let me write in the words. The probability of the event that how do we write? Whether the event that minimum value is
Yes.
exactly k. So how do we decide it? This is greater than k. Let's think in this way. You are actually supposed to find, when we are writing greater than k, from here to here, all the possible. And there is k plus 1 also extra. So if you find out the difference between these two, what you get? Exactly k you get or not?
Yes, sir.
It means, suppose you have to find P m is equal to k directly. I can write as a P m greater than k minus P m greater than k plus 1. Correct?
Yes, sir.
Is it clear? Now I can just write it 6 minus k to the power 5 by 5 to the power 5 and minus 6 minus k plus 1. K minus 1. So what do you get? 5 minus k, correct?
Yes, sir. 5 minus k to the power of 5.
By 5 to the power 5. So I can just write
Yes,
that
sir.
6 minus k to the power 5
Minus
minus
5
5
minus
minus
k
k
to
to
the
the
power
power
of
5
5.
divided by 5 to the power 5.
5 to the power
Now
of
let's
5. Yes,
substitute.
sir.
Yeah, so you can see that these options are also given in that. One, maybe this is not given, but this is given. But it means you have to
Yes, sir.
evaluate it. Correct?
Yes, sir.
So let's calculate what we get it here. If you substitute Pm is equal to 2, what we getting?
Yes, sir. 4 to the
6.
power of 5 minus 3 to the power of 5 by 5 to the power of 5.
Yes. And do we get the same thing? No. We don't get the same thing. Correct?
We need to calculate and see.
Please calculate, check. Are we getting this thing? By the way, I think the denominator is 5 to the power 5. Then 6 to the power
Yes,
5
sir.
they are given, I think. So 6 to the power 5 they are given actually. So that's correct. So maybe some calculation is there. 6 to the power 5 and 5 to the power 5. There's no
Maybe
relation.
maybe we need to multiply multiply and divide by 6 to the power of 5 and 5 to the power of 5.
But it's not going to be like a feasible thing, you see, because there's no chance that it's going to be that. You notice?
Yes,
So I
sir.
think A option is incorrect. What about the B option?
B is coming exactly, sir.
B is exactly correct, correct? Yes.
Yes, sir.
So B is exactly correct. The expected value of the minimum element of S. So expected value of minimum value of S means that it can be 1,
1.
it can be 2, it can be 3, it can be 4, 5, and so on, correct?
Yes, sir.
So basically, this now not only that, the minimum, this question is saying the expected value of minimum element of S. So how do you find it?
Don't understand what they're asking, sir. Minimum
Sorry?
value of. Don't understand what they mean by minimum value of S, sir.
Means when you are selecting those elements, read the question again. See here. Okay, read it. 5 integers are each selected uniformly at random from range 1 to 5 inclusive
Yes, sir.
and put into a set. Each integer is selected independently of the others.
Minimum element of S should be an integer, no, sir. Then.
So minimum value, like suppose you selected 5 integers out of it. It can be 1.
Yes, sir. But this one they've given a fractional form, sir.
Sorry, no, expected value cannot be integer. Expected value can be anything, fraction also, no problem.
How, sir?
Expected value means mean we have to find, mean, expectation. You understood?
Yes, sir.
E of x we have to find. Have you not done many times before? What I think? E of x, the summation, xi pi. I goes from 1 to whatever I have done, correct?
Yes, sir.
It means I have to find out the probability of each such and then multiply and add them.
Yes, sir.
So what we do for that?
Minimum value 1 and its probability. Minimum value of 2 into its probability. Minimum value of 3 into its probability. So on.
Sorry, I deleted it. That's correct. B, part C we have to check. So expectation of M is nothing but 1 into, and we substitute 1 there. So 5 to the power 5 minus 4 to the power 5 divided by 5 to the power 5 plus 2 into 4 to the power 5 minus 3 to the power 5 by 5 to the power 5. Then 3 into 3 to the power 5 minus 2 to the power 5 by 5 to the power 5. 4 into 2 to the power 5 and 1 to the power 5 by 5 to the power 5. And finally, 5, correct?
Yes, sir.
So 5 into 1 to the power 5 minus 0 by 5 to the power 5. You can take 5 to the power 5 common from all of them. And what we get it here is 5 to the power 5 minus 3 times 4 to the power 5. And 2 and 3 minus 5 times, sorry, minus 2 and plus 3. So plus 2 minus 1. This is 1, no? 1. Okay, sorry. 1 times 4 to the power 5. Then 3 minus 2 again 1 times 3 to the power 5. Correct. And again 1 times 2 to the power 5. Correct. And again 1 times 1 to the power 5. Is it making sense, Cornish?
Yes, sir.
Yes. So basically we have to add all of them and divide by this. So first term we leave it because it's going to be 1 anyhow. We add this much and then divide by 5.
So D will be false.
Ah, D will be false. How it makes sure?
Because it's less than 1.
Yes. So option C should be correct. If it is, and they're asking that what are the number of points at which this entire function is non-differentiable. So essentially we have to find out the function fx. After that we don't bother what is happening here because it will be easy. And here this part is nothing to do with the function itself, because it's only contributing some other number of points of discontinuity or non-differentiability. So
Yes,
this is only the increasing the number of points of non-differentiability by 2 elements, because this is, if you check the discriminant greater than 0, the roots of this will be only increasing the number of non-differentiability. So our main goal is to find out the function. So how do we do the function? How do we find the function? Let's see. So you notice that the product is given there, and here we have to understand this thing, that this is k goes from 1 to infinity. There's a 2 here, there's a cos 2x. So maybe it's actually inviting us to apply the formula of cos 2 theta, but cos 2 theta has sine, yes, of course. Sine, why we are using it, you know that. So this is going to be what? 1 minus 2 sine squared x by 3 to the power k. And this is divided by 3. You notice what will happen, that k goes from 1 to infinity. There's 3 minus 4 sine squared x by 3 to the power k, correct?
Yes, sir.
And this is actually inviting us to use the identity of sine 3 theta, if you just think it correctly. Because I can multiply and divide by sine x to the power 3k, correct?
Yes, sir.
So what we get it inside is k goes from 1 to infinity, 3 sine x to the power, x by 3 to the power k, and minus 4 sine 2
x by 3 to the power of k.
And whole divided by 3 to the 3 into
3 sine x by 3.
Okay. In the numerator, what we get is sine 3 theta, which means,
yes, sir, sine x by 3 to the power of k minus 1.
Exactly. So sine x to the power x by 3 to the power k minus 1. And denominator, I have 3 sine
x by 3 to the power of k.
So let's start now substituting the value. But notice one thing, that here I don't have
to. The terms will cancel each other out.
Exactly. That will cancel. Yeah, but there is one point. Where do we stop? We don't know, because this is infinity. So in this situation, what we should do? We should write in this way, that I'm just finding the limit n tends to infinity, but I'm finding the product k goes from 1 to n. In this way, I can stop at n, and then we apply the limit n approaches infinity. Okay, correct?
Yes, sir.
So can you tell me, okay, let me write this first and then you tell me what we are left with directly. Or should we write and then see cancellation? Let's see. Because we cannot directly guess what will happen. So the first term will be sine x
X
by
by x by 3 sine x by 3.
second term will be
Sine x by 3 divided by 3 sine x by 3 square.
and so on. So can you get what we get here?
Sine x by
The
3
power
to the power of n
3 to the
minus
power
1 by 3 sine x to the power of n. X by 3 to the power of n.
3. Good. So what we
Yes,
get
sir. We'll
this
be left with
cancellation.
sine x by 3 to the power of n sine x by 3 to the power of n.
Exactly. Very good. It means what we are achieving that there is a sine x and divided
We can take the 3 to the
sine
power
of
of n
x to the
outside
power.
also.
No, why can you take this? Is actually index of n.
Yes, sir.
Now you notice that when n approaches infinity, what happens to this
Sine
guy?
x
This is very
tends to.
close. Yeah. So no,
Yes,
this
sir.
is
We
angle
can
is
write
x
that
by 3 to the
as
power.
x
So
by
can
3
you
to the power of n.
exactly? So can you tell me what the answer will get total? Sin x by x,
Yes, sir.
because this will cancel, na? This one. X will be correct.
Yes, sir.
So once we get yes, you understood, Ganesh?
Yes, sir. Understood, sir.
So this we get sin x by x, and once we get sin x by x, it's easy because they are only asking x f x. It means this is nothing but sin x box, then sin x mod, then x minus 1, and mod of x square minus 3x plus 2. Is it clear?
Yes.
And of course, they have given some interval. Let me check what interval they have given or not less. Zero to 2 pi. Otherwise, how do we find the integer? So 0 to 2 pi, we have to find out the number of points of non-differentiability. So there is no such problem after this, I guess. So please take the
Yes,
notes
sir.
and then.